Hello everyone. We are learning about the linear programming problems. In the previous video we have learned what is linear programming, what is its importance and what are the parts or components of a linear programming problem. Here in this video we will learn about the solution of linear programming problem when we have been given a linear programming problem which is already constructed. Before going to the solution of the linear programming problem, we have to understand about the graphical problems, graphical parts of it. What is the corner point method? Because we are going to find the solution of the linear programming problems by using corner point method. Here you see, we have already learnt in the previous videos of linear inequations. How to find the solution by graph of a particular linear inequation. See, here we will be having some of the constraints, some of the linear inequations. Suppose we draw the diagrams of them on the graph. Here we find that two types of regions we can have for the two or three inequations. That may be bounded or it may be unbounded region. What is the meaning of bounded region? Suppose this is the representation of inequation first. And the region of this solution, region of this is downwards, means towards the origin. Then we draw the second inequation here and we find the solution region is also towards the origin. Then this becomes the common region of them. This is the region which is having the solution of both the linear inequalities or inequations. Also we can say that this is the region in which every point is satisfying the inequalities or the constraints of the LPP. This is known as the feasible region. So here feasible region is O, A, B, C. This is the feasible region. Suppose we have another case in which we draw the graphs for both the inequations or the constraints. That is number one is here, but this is outwards, means this is against the origin side. The solution of this lies on the side where the origin is not lying in that. Second one, when we draw this, we find the solution of this also is in the region where the origin is not there. And when we see the common solution of them, the region which is satisfying both the inequations is unbounded. This is outside, away from this. This is Yamaki. So here we find the feasible region is unbounded region, and that is here A, B, C and all. A, B, C and all. Then what are the corner points? See, the corner points are these common one. A, B and C are the corner points here. And the corner points in this also are A, B and C. So like this we can find out the corner points of the bounded region or it may be unbounded region, and after finding the corner points we will try to find out the solution of the LPP. What is the algorithm to find the solution? We will discuss just now. The algorithm to find out the solution of LPP, that is linear programming problem. Here we have, first of all we will note down the LPP and its constraints. And then in the first step we will draw the graph of the inequations by taking their corresponding equations and converting them into the intercept form, or otherwise by making the table of the satisfying points, as we have learned in the previous videos of the solution of inequations. The second point is find the feasible region that may be bounded or unbounded. We have just now discussed about this, how to find out the feasible region. The third point is find the corner points of the feasible region, whether it is bounded or unbounded. and we will take the coordinates of all these corner points. Then the last point is find the value of the objective function z at all these corner points. Some point of them may show the minimum value of z and some point may show the maximum value. So wherever we find the minimum value of z, that is the minimum value of the objective function and at particular values of x and y. Similarly, where we get the maximum value, that is the maximum value of the objective function z and at that particular points of the values of x and y. We will discuss now some examples to understand this more clearly. So we are going to discuss the first example here, that is maximize z equal to 3x plus 4y. This is the objective function subject to the constraints x plus 2y less than equal to 8 and 3x plus 2y less than equal to 12. And the non-negativity constants x is greater than equal to 0 and y is greater than equal to 0. See here, since we have non-negativity constant, the values of x and y are positive. This is the reason that we draw the complete graph in the first quadrant only. Our solution of LPP lies in the first quadrant. Now according to the algorithm, we find the solution of this. For the first inequation, we take the corresponding equation, that is x plus 2y equal to 8. To convert into the intercept form, we divide the equation by 8. It gives us x by 8 plus y by 4 equal to 1. It means the points on the x and y axis we are getting 8, 0 and 0, 4. We mark the points here 8, 0 and 0, 4 and join the line. Now we see origin 0, 0 satisfies this inequation. 0 plus 0 is less than equal to 8, yes. It means the solution of this lies towards the origin. So we mark it by the arrows. The second inequation is 3x plus 2y less than equal to 12. We take the corresponding equation to this, that is 3x plus 2y is equal to 12. And to convert it to the intercept form, we divide it by 12. That is x by 4 plus y by 6 equal to 1. It means the points on the x-axis and y-axis we are getting are 4, 0 and 0, 6. We mark the points 4, 0 and 0, 6 and join this. And here also we find 0 plus 0 is less than equal to 12. It means the solution region of this also contains origin. So we mark the arrows here to show the solution region. What is the common solution? That is the feasible region. And here we find the feasible region is OABC in the first quadrant. So we will return the feasible region is OABC. What are the corner points? Corner points are A, B and C. A is 4, 0. B is, we can see from the graph, this is 2, 3. And C is 0, 4. After finding the corner points, we find the value of z at each corner point. We draw a table like this. We mark here corner points A, B, C, x coordinates of them, y coordinates of them here, and then we find the values of z at different points. See, for A, x is 4, y is 0. So this will be 4, 3 is 12 plus 0, that is 12. At B, that is 2 and 3, so 2, 3 is 6 plus 3, 4 is 12, 6 plus 12 is 18. And then C, x is 0, y is 4, so 0 plus 16, that is 16. The maximum value we are finding is 18 here, and that's what we need to find. So we can write therefore maximum value of z is 18. At what values of x and y? At x is equal to 2 and y is equal to 3. This is the answer. Suppose we are asked to find out the minimum value. We find here the minimum value is also here 12. And that minimum value of z is 12 and x equal to 4 and y equal to 0. Like this, we can find out the maximum and minimum values of the objective function by using the corner point method. In the next video, we will learn about the manufacturing problem or product problems, and in that we will learn how to form the LPP for the given problem and also to find out the solution of it. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.